All right, so let's start section 4.6, which is on limits involving infinity. All right, and in this video, I'm just going to show you kind of graphically what we mean by these limits involving infinity. And I've started off with a rational function, the graph of 2x minus 1 over x minus 3. And we know that rational functions like this, we've talked about this before, that they have asymptotes. And the asymptotes for this function are at x equals 3. So I turn that one on, that red dotted line at x equals 3. And that's because the number 3 causes division by 0 for this function. And then y equals 2 is the horizontal asymptote. We're going to talk about in the next video how to actually calculate those horizontal asymptotes. But for now, you can kind of see that this graph sort of flattens out on the right-hand side and the left-hand side towards y equals 2. All right. So from a perspective of limits, let's kind of scoot this guy over. All right. Let's talk about what's happening at x equals 3. All right. So as I'm traveling along this graph, left to right, so as I'm coming in here, so I'm traveling along this graph, as I get close to x equals 3, I'm on the left-hand side, the y-coordinates are diving down towards negative infinity. Okay, so we learned notation for this, right? As I'm getting close to 3, the limit as x approaches 3, we're on the left-hand side, so remember we get that little superscript there. The limit as x goes to 3, from the left of f of x. This time, instead of being equal to a number, these y-coordinates are decreasing without bound. They're getting hugely negative. So we say that this answer is negative infinity. So you can see that, especially at vertical asymptotes, you can get limits that are equal to infinity. All right. And likewise, as we're traveling towards 3 from the other direction, so as I'm headed towards 3 from the right-hand side on the x-axis, okay, then the y-coordinates are headed up like this. All right. So we would say that the limit as x approaches 3 from the right-hand side of f of x would be equal to positive infinity. Okay, because those y-coordinates are getting hugely positive, going to positive infinity. And by what we learned last time, because the left-hand limit and the right-hand limit are not equal, we would say overall that the limit as x approaches 3, without a little superscript left-hand or right-hand of f of x, we would say this one does not exist. So that overall limit does not exist. All right, so that's one kind of limit involving infinity. The other one, if we're talking about the other asymptote, these limits are not equal to infinity. Okay, so these are happening as we go towards x equals infinity. So as I'm traveling along the x-axis, okay, so I'm headed x going towards positive infinity here on the x-axis. The y-coordinates are flattening out, okay? They are headed towards this horizontal asymptote, all right? So this time, our limit is going to be as x approaches positive infinity. And the y-coordinates are headed towards 2. Over here on the left, now we're having x traveling towards negative infinity. So we would say the limit as x approaches negative infinity. These y-coordinates are also approaching 2. They're kind of coming up from the underside, but they're getting very close to 2. So we'd say the limit of f of x as x approaches negative infinity is equal to 2. All right. Okay, so let's look again graphically at another one. Let's see, let's get rid of this graph and its asymptotes. We're going to look at this rational function, y equals 1 over x plus 2 squared. Okay, and its asymptotes, we can see its vertical asymptote is going to be at x equals negative 2. You can see that causes division by 0. The y-coordinates on the left and the right, though, are flattening out at the x-axis. So its horizontal asymptote is y equals 0. I've got a green dotted line. If you kind of squint, you can see that on the video. All right, so let's just use our limit notation to kind of say what's going on with this function. Okay, so the vertical asymptote, as I'm getting close to negative 2, let's go from the left-hand side. So as I'm approaching x equals negative 2, if I kind of travel along the function that way, those y-coordinates are getting hugely positive. So I would say that the limit as x approaches -2 from the left, because I'm on the left-hand side, of f of x equals positive infinity, because those y-coordinates are getting hugely positive. And then I can kind of say the same thing on the right-hand side as I approach x equals -2 from the right. Those y-coordinates are also getting hugely positive. So I would say the limit as x approaches -2 from the right, that is also equal to infinity. Okay, so unlike the last one, as I approach -2 from both sides, I'm getting positive infinity for both of them. All right, so I would say that the overall limit for this one does exist. The limit as x approaches -2 of f of x. From the right and the left-hand side, they agree that this is going to infinity. Okay, so remember, the function does not have to be defined at -2 in order for the limit to exist. It exists, but it is infinite. All right. And let's do the limits at infinity. So those are the limits that are equal to infinity. Let's go ahead and talk about the limits at infinity. Okay, so now we're talking about as x approaches infinity. So as we're heading out this way on the right, we would say the limit as x goes to positive infinity of f of x. Okay, the y-coordinates are flattening out, getting very close to 0. So we'd say this limit is equal to 0. Okay, because all those y-coordinates, in fact, the resolution on the screen, you can barely see that it's not equal to 0. It is very close. All right, and the same thing happens over here on the left. We would say the limit as x approaches negative infinity. So as I'm heading out this way, those are also equal to 0. These y-coordinates are also flattening out, almost exactly equal to 0. All right, so again, limits that are equal to infinity, limits at infinity. All right, so let's take one more look. We're going to look at a couple of polynomials. Look at this function here. Okay, so this is the graph y equals -x cubed plus 6x squared minus 9x. All right, so this is a polynomial. It does not have any asymptotes, but it does still have limits as x goes to infinity. All right, so let's look as x goes to positive infinity. So as we're heading out this way. Okay, so as x goes to infinity, I mean, this graph, even after I get out here at like x equals 12, the graph is there. It's just way off my screen. Hugely negative, right? Down there somewhere so I can't see it. So a long time ago, way back here at 3, 4, 5, 6, these y-coordinates got hugely negative. They keep going, all right? So this one, we would say the limit as x goes to infinity of f of x is negative infinity. All right, so as x goes to positive infinity, the y-coordinates, remember f of x is another name for y, the y-coordinates are going to negative infinity. All right, and then we can also think as x goes to negative infinity, get rid of these guys. All right, so now we're talking about as x goes to negative infinity. All right, again, those y-coordinates are there. You can't see them. They're sort of fallen off of my screen. All right, but as x goes to negative infinity, the y-coordinates are headed upwards towards positive infinity. So we would say the limit as x goes to negative infinity is positive infinity. Okay. All right, so there are no vertical asymptotes, so we don't have any need on a polynomial to talk about left-hand and right-hand limits. All right. So let's do one more polynomial. We've done 2 rationals. Let's do 2 polynomials looking at the graph. Zoom that guy in a little bit. All right, so again, as x goes to positive infinity, so as we're heading out this direction, the y-coordinates are becoming hugely infinite. So we would say the limit as x goes to infinity of f of x is infinite. Likewise, as we head out towards negative infinity, the y-coordinates are also getting hugely positive. So we would say the limit as x approaches negative infinity is also positive infinity. Okay, and that's just saying as you go out to the right, as you go out to the left, this graph rises on both sides. It's going to infinity. Okay, so this is what we mean by this limit notation. We're talking about graphically what's happening to the y coordinates as we approach different values of x. All right, so in the next couple of videos, I'm going to show you how to calculate these answers without knowing what the graph looks like, because obviously we don't always have Desmos on hand to tell us exactly what the graph looks like. And also, like last time I showed you, sometimes Desmos doesn't have a clue as to what's going on a graph. All right, so we'll see you on the next video.